All right, good afternoon. This is the 10th or 8 of 10, 8 of 10, 2025. Creative exam, okay, will be right after grade 10. So, if you are a creator watching this video, watch it all the way to the end. And then you will know exactly what to do. This question will, questions on this one, cell potential or electrochemistry. Okay, this is a particular unit that is always being tested, and it's always appearing in the exam papers or other exams. So it will appear this year too. So over here, I'll be showing you how to calculate cell potential. All right, and it's part of electrochemistry. So as we go through, we'll also show you how to write cell notation, how to identify anode and cathode, the ones that undergo oxidation and reduction of anode and cathode from a chemical reaction. And also I will be explaining to you what are the different ways they can set questions on this particular topic. So stay tuned, watch to the end, and let's start. Okay, first let me explain this diagram here. This is what we'll call it a voltaic cell, or we call it galvanic. It's one of the electrochemical cell. Galvanic cell it generates electricity through spontaneous reaction, and the other one, electrolytic cell, it uses up electricity and to drive a non-spontaneous reaction. So let me explain this. Now you see one electrode, it's copper, the other one is zinc. First thing first, this is the salt bridge, okay? Salt bridge. So what's the job of the salt bridge? Salt bridge serves as the link between the two half cells, okay? That's where electrons flow from one cell to the other, and it completes the circuit. Without the salt bridge, this circuit will not work. And we have the symbol up there, okay? So if you're studying electricity, okay, this is the symbol of voltmeter. What's the job of this voltmeter? This voltmeter is placed here to measure the voltage of the entire cell. And the voltage of the entire cell is the result of the difference in the voltage of the two cells, which is called the cell potential or electromotive force, EMF. Okay, the other thing, you look at this one, Cu, and then we have Cu2 plus, Zn and Zn2 plus. Now you have to know that these are the electrodes, cathode, anode, salt bridge, and what's this liquid over here? They are called electrolytes. These are the basics that you should never forget. Electrolytes, all right, and over here, whenever the electrode is used, copper, a salt of copper is used as an electrolyte. Likewise for zinc. So salt of copper can be CuNO3, okay, CuSO4, CuCl, as long as copper ion is there. You cannot put copper electrode and you put a different salt over here. Okay, the salt should be of that electrode. Likewise for zinc, it can be zinc chloride or zinc iodide, all this. Okay, so sometimes they will just ask you, give an example of a salt that will be used over here. So it is always a salt of copper, salt of that electrode. In this case, copper. Over here, zinc. Okay, good. That's that. Now, cell notation. What is a cell notation? Cell notation is a very simple way to represent the voltaic cell, electrochemical cell. All right, so to write cell notation, okay, we normally have it this way. I'll just put an example over here. Ag, solid, okay, Ag plus, and then we give Cu 2 plus and Cu solid, AQ solid. Okay, so this is how a cell notation is written. Now let me explain to you the parts. If it is like this, you will not know which one is cathode and which one is anode, or which one is the oxidation, which one is reduction. So the first part of the cell notation, it's always the first part is always the oxidation part, or the one that occurs at anode. And the second part is the one that occurs at the cathode or reduction part. And where is the salt bridge? Salt bridge, you see the two strokes coming down over here. This is the salt bridge over here. Okay. Salt bridge. Okay, so now that already explained this, okay, now if you look at the anode, the first part here, first species here, that's the reactant side. The second is the product. First one under the cathode, that's the reactant. The second is the product. Okay, so now I will explain this, so let's look at this. One way someone has said option, they will give you a diagram like this and they will ask you to write the cell notation of that particular diagram. In this case, we have copper and zinc, so we are going to write a cell notation for this. Now there is a problem here. You see, copper and zinc, they didn't give us whether it's anode. They didn't say this one is cathode, they didn't say this one is anode, or this one is anode, this one is cathode. So we don't know. But how do we identify one that will come on the anode and one that will come on the cathode? That's why you're going to use a periodic table and look under your reactivity series. And the element that is the most reactive, the one that is higher in the reactivity series, it will be the one that will oxidize. Or we say it will be the one that comes under anode. And the one that is least reactive or below is the one that will undergo reduction, or the one that will be reduced at cathode. Okay, so we have to understand this. Now let's compare copper and zinc. According to the reactivity series, zinc is way above, copper is below. So definitely this one is our anode and this one is our cathode. Okay, good. Now we already know our anode and cathode. We can write this. Okay. Now when you write the cell notation, you have zinc, anode with zinc, you write zinc N, that's solid, that's an electrode, and then you have this ion, that's a product now. It will lose electron, 2 plus, a Q, and then salt bridge over here, we put a 2 line, and then look at copper now. This one is the reactant, Cu, 2 plus, it will gain electron, reduction is gain, or we write oil ring. Use this to remember. Oxidation is loss, reduction is gain. And then put a line, and then that's what the product was. CUS. Alright, good, done. You get 1 mark already for this. That's how you identify the anode and cathode, and you write the cell notation. Now the half reaction. So we already identify which one is anode and which one is cathode. We can write the half reaction. For anode, it will be Zn. Okay, electrons on the right side. Solid, always put the state, then 2 plus plus 2 electrons, use 2 electrons, and AQ. Good. Okay, so now let's look at cathode. It's this one. Okay, Cu 2 plus AQ. Oh, sorry, gain electrons, so it will be plus 2 electron, produce Cu solid. Okay. Now the cell potential. Okay, how do we calculate the cell potential? To calculate the cell potential, we use this formula. E of cell is equals to E of cathode minus E of anode. We use this. Alright, so now that we identify the anode and cathode, we have the equation here. So we just go ahead and then substitute. So where are you going to get these values? You come across here, and that's where you can get it. This table is a standard electrode of half cell Now there is an important point written down there. It says written reduction, only reduction part, not oxidation is written yet. So let's see. Now this one, cathode reduction, that's this copper. We check the value over here, copper. It's plus 0.34. So E of copper is plus 0.34 volts. Okay, so we write 0.34 volts minus. Okay, on this side now, I know this zinc. All right, over here, that's the reduction half. That's the reduction part of anode is given, not oxidation. So oxidation will be reversing it. So it will be, it's what? Reduction is, wait a minute, let's see. Zinc is minus 0.76. Okay, so I'll put a negative over here and then 0.76. Okay, so when you multiply it, we should get 1.1 volts. Okay, so that's the cell potential. Okay, I will verify this again. Okay, this another thought that comes to my mind, whether it's negative, so we should change it to positive. Okay. Anyway, so that's how you calculate. All right, so that's one way. If you're given diagram, you might be asked to do all these things. Okay. Now, let's look at another thing, how to write cell notation. Okay, you might be given the cell notation and you ask to find the electro EMF. So you might be given something like this: Ag solid, Ag plus, Cu2 plus, and Cu solid. You might be given something like this and they ask you to write the reduction equation, oxidation equation, and B, cell potential. Okay, you might ask to do all these things. So from this, you have to know that the salt bridge separation, the one on the left or the front, that's oxidation, the one reduction. So oxidation is this one. So you write the first part. The first part is the product reactant. The second is the product reactant. Okay, reactant, product. Okay, so this one is oxidation. So you write Ag produces Ag plus electron. Reduction, Cu plus 2E produces Cu solid. Now down cell potential again. You already have written this. Look at this, and then E0. And okay, it's not working properly. Okay, so we have E0 cell is equals to E of cathode minus E of anode. Okay, so cathode, when you look at this, it's copper, and copper is 0.34 minus, and then when you look at silver is 0. What's that? That's for oxidation, so silver will be minus. The value here is 0.8. It's positive. That's for reduction. But when you look at oxidation for silver, it will be -8. Okay, so 0.3 plus 0.8, we should get 1.14 volts, and it's positive. What does the EMF cell potential tell us? If the cell potential is greater than 0, that means the cell is spontaneous. It gets a spontaneous reaction. And if it is, let's say, below 0, that is, it's a non-spontaneous reaction. That means you're going to use an external power source to force the reaction to take place. And if E0 is equals to 0, that means there is no net reaction. Okay, it's in equilibrium. All right, I got this a very long video. Thank you for watching. Thank you for following. And this, I want you to share, comment, like, and if you want anything that I will explain, let me know. So follow, and the next video, it will be on using Nernst equation to calculate cell potential. Good luck for your exam. Study hard, study smart.